All right, thank you, everyone. Sorry about being fashionably late. We like to create anticipation before any of our presentations. A little bit of background about me is that I've been in industrial communications for about 28 years, maybe a little longer, specifically in oil and gas. Did everything from field connectivity to network infrastructure, whether it was fiber, copper, wireless. Prior to coming to T-Mobile, I was actually a contract solution engineer for Chevron. Did a lot of proof of concepts for them in California. This is about 5 years ago. I mean, IoT's been around. It's just got renamed recently. It's basically communications to remote devices, sensors, and basically taking the real world and digitizing it so we can represent it differently and start applying all kinds of analytics to that as well. So it's an exciting technology to be in. It's growing. I'm getting really busy with a lot of companies like yourself, anywhere from platform providers to OEMs that are building sensors for IoT and deploying it. And everybody, at the end of the day, it's about communication. So it's whether you go with LoRa, Sigfox, or NB-M1, it's about communication. So as far as the end user is concerned, they're agnostic to however you provide that connectivity. So that's, I learned that from Chevron. Now that I'm with T-Mobile, obviously we like to push our technology, our network, but there's other companies, AT&T, Sprint, Verizon that also offer that. And actually, the end goal is really to provide connectivity for all these sensors out in the field, so we can hopefully make our lives better. So with that, I'll get started. If you have any questions, don't feel free to interrupt, and hopefully I can answer the questions that you guys have. So obviously, this is our tagline. We're the end carrier. We like to disrupt the industry, and so we've done a good job over the past years. Everybody's talking about the acquisition, how it's going to make prices go up. Well, historically, T-Mobile has driven prices down in the wireless industry, from eliminating contracts to introducing competitive pricing and unlimited type of plans. So that's historically what we've done, and we'll continue to do that, I believe. So everybody talks and asks, one of the first questions I get is what's going on with the Sprint acquisition. And all I can say is I read what's online. There's a little bit of talk internally, but there's a lot of plans going on. Apparently, we've been approved by the DOJ with conditions for the acquisition, and so we have to comply with that as far as, I think, it's spinning up a fourth carrier, which is, I believe, Dish Network. We're going to divest Boost Mobile, provide access for a certain time period that the DOJ has specified. So there's a fourth carrier. The biggest concern is, going down to 3 carriers, is pricing going to go up for the consumer? So we're going to address that. In addition to it was 12 states, I believe. Now there's 15 states that are trying to sue to block the acquisition or the merger, if you want to call it that. We'll see what happens, but that's all I know about it. And whatever you read online is, depending on what you read, it may be true, maybe not true. But yeah, T-Mobile's excited because with the acquisition of Sprint, with the spectrum assets and the fiber that Sprint owns in the ground, that's really part of our 5G deployment nationwide. So we're excited, and we're happy to have the Sprint family included in our family moving forward. Oops. So what's T-Mobile doing? Well, we're on the path to 5G, just like all the other carriers. Just provide, hopefully nationwide connectivity. When you think of 5G, think of really 2 things. I like to keep it very simple. It's higher throughput, higher bandwidth, and lower latency, where we're looking at multiple gigabytes bidirectionally, and also lower latency in the 20 milliseconds. So essentially, if you take those statistics or those specifications, you look, wireless will be competing directly with broadband, okay, for wireless perspective. If you look at other countries really have a big focus on wireless. They have been, because really the U.S. started out putting wireline in the ground, whether it's copper and fiber. That's what really started the communication era, as far as telephones and eventually the internet, providing services to consumers to the internet. So the other countries are kind of backwards, where they have actually started with wireless, so they're kind of ahead of us right now. And not that we're playing catch up, but we've got a lot of things to do as far as densifying the United States with cell sites and providing that connectivity in regards to 5G. So there's other details of 5G, and newer technologies as far as virtualizing the radios, edge computing, which you guys really don't hear about, but that all boils down to when you hear about 5G for autonomous automobiles and trucks, like what Telsa's doing and all these other companies. And I think Bell's got a project for air taxis, a project here in Dallas. It's all about the latency and the speed of the network and how they communicate. Okay. 4G technology is where we're at today. We're pushing in some cities. I know all the other carriers have announced 5G in certain areas. And the reason for that is that it's not going to be nationwide right away, is because it requires densification, adding small cell sites to these metropolitan areas to provide the mid-band signal that gives us the speeds. It's no different than your wireless at home, that the higher the spectrum, the shorter the distance that that signal travels. So we've got to densify, starting with the cities, and eventually move out. Now, will we have complete densification in rural areas? Most likely not. So the speeds may not be as fast, or the latency may not be as fast as in the metropolitan areas. So with that said, there's other technologies. M1 is included in 5G. Narrowband, T-Mobile launched initially with narrowband. That's really what we're launching for IoT. It's low bandwidth for devices, and from a module perspective is when you're dealing with remote sensors. A lot of these locations, especially in industrial applications, you may or may not have power to the radios or to the sensors itself. So you want to conserve battery, and I'll get into narrowband M1 and some of the other technologies that are out today. And then 2G, which is really the old legacy technology. One thing that I want to mention about 2G, I think 2G will be around all the time, especially with devices that are roaming, like your phones. If you go to third world countries, they don't really have, they can't afford to upgrade their networks, from a wireless perspective. So 2G will always be around, and a lot of your modules, a lot of your phones still have 2G fallback. So there's plans for us to sunset both 2G and 3G in 2020. We'll see what happens, because there's a lot of applications where, like tracking devices, that when they go into third world countries, it's a 2G network, you want to still have them continue to function. So let's talk about T-Mobile's narrowband. So the standard is really operate in a licensed spectrum environment. So it's not for unlicensed, it's certain spectrum. With T-Mobile, it's currently bands 2, bands 4, and our guard band, which is band 66. We do have plans launching it on 12, which is 700 megahertz, and also eventually our 600 megahertz band, which is band 71, which gives us a lot further propagation as far as distance. Want it to be scalable. Again, narrowband is really small bits, so it's really designed for sensors. I see a lot of companies developing narrowband applications for mobile type of applications tracking. It's really not designed. Will it work? Yes, but it's really designed for fixed type of wireless applications, because narrowband doesn't it doesn't roam very well. So when it moves to a different tower, it has to negotiate a brand new connection, and that's when most of your energy is consumed, when it's negotiating a new connection. Whereas your traditional phone, for example, it roams, so it knows if it switches, it'll switch to a different carrier. It doesn't, a different tower or radio LAN, but it doesn't have to do a full renegotiation because the network already knows it's online. And then security, that's a big issue with IoT, all different things. Grade security and standard keeping your network safe. There's still ways to to get into the NB-IoT network, pretty complex, but it's vulnerable just like anything else. Nothing's 100% secure. But as far as the cellular communication itself, that is somewhat secure because we're basically, and all carriers do that, so we encapsulate your data at the module, and through our network, then we hand it off to the customer at that point in time. So narrowband IoT, really lots of applications. I mean, you guys see them now. It's for building monitoring. Again, you're monitoring information, whether it's a PLC in an elevator or it's the HVAC system, to see what's, how to optimize that to save energy and money, etc. Make your system more efficient. There's street lights, there's parking. These are the usual ones that you see all the time. Asset tracking, again, lost your suitcase. And then metering, as far as utilities, whether it's water, electrical. I know there's someone here that's developing it. There's a lot of companies doing that as well. It's a big market, for being able to take that data and then bring it in without having to roll a truck like some of the utility companies do now to reach a meter. Won't have to do that anymore. And then equipment monitoring, whether it's for monitoring vibrations to understand maintenance, preventive maintenance for like bearings, etc. There's a lot of different applications for narrowband. Some of the features and benefits is, again, narrowband, if it's used and deployed right with the right use case, it'll conserve battery because it doesn't use a lot of energy. It typically goes to sleep and wakes up every so often. So, it's not using energy or very little when it goes into sleep mode. Again, bands 2, 4, 12, 12 and 2020. We do have narrowband rolled out in a lot of areas. We've got really good coverage on our bands 2 and 4 right now. We will launch band 12, which is the 700 megahertz in 2020, and expect us to launch it on our band 71, which is 600 megahertz, which will give us a long range of coverage. On the average, narrowband, the way it's with a small packet and how it's encapsulated, it'll actually propagate further on the same spectrum, about 50% further roughly, depending on the environment, than your phone does. So if your phone connects to a tower at say 20 miles, narrowband, it'll reach 30 miles from the tower. That's important because that gives you coverage without having to add additional towers. And that's a whole different story we'll talk about towards the end of this. Power saving modes, we talked about that, and there's enhanced, what they call DRX support, enhanced deep sleep for battery life, SMS capabilities, and then certification. We manage narrowband devices different than your phones. So we have a platform that manages it. And narrowband doesn't use IP addresses, so it's not IP. So that's part of how it's a little bit more secure than devices that have IP addresses on the network. But we have a platform that manages and knows exactly how to get to that device. Okay. So here's some differences between narrowband Cat-M1 and then Cat-1. So basically what you'll see is that narrowband really slots smaller data packets. Your download max is 250 kilobits. Your upload is 230. If you look at M1, that gives you more. Narrowband doesn't support voice, so important. It's not only not designed for any type of voice applications. Whereas if you have a voice application but you don't want to go to a true Cat-1 solution, then M1 is probably where you need to go as far as your use case. So if you look at the Throughput is 1 megabit, both up and down. It does support voice or VoLTE, and there's SMS support. So your battery life, depending, again, it really depends on your pulse cycles. How often are you communicating with the device? So, they say narrowband up to 10 years. That's probably pulling it every once a day, maybe once every other day. Whereas if you change your polling rate to poll every hour, 15 minutes, you're going to significantly reduce your life. So I always kind of laugh when I see OEMs that say, hey, our battery can last for 10 years. My issue with that is that the devices haven't been out 10 years, so how do you know? So you got to kind of be careful with that. And they really understanding what their poll rates are. M1 I'm not that familiar with because our network doesn't support M1. And the saying that we have right now is that we're going to purchase a M1 network from Sprint for $26 billion. So I expect that to be, when both companies finally merge or technologies come together, they have customers that we're not going to let hanging. So we're going to integrate the M1 network into our network eventually. And again, they're saying that 5 to 10 years. And then you look at your Cat 1 that's been around for a long time, basically LTE devices, different throughputs. It's 10 megabits download and 5 upload. Look at your millisecond. Under 50 milliseconds, M1 is under 1 second, and then narrowband is 10 seconds, less than 10 seconds. Narrowband devices typically aren't that critical, so you don't really need low latency, whereas with maybe Cat M1, different use case, you might need higher, and then Cat 1 itself, that's traditional like LTE devices. And again, there's really no saying for battery life because people use that differently. Phones will probably have anywhere from, I'm going to say Cat 4 device all the way up to 6. Your phones, you're going to get the best speeds on your phone. That's the way they're designed. So here's some of the use cases. Again, we kind of talked about this, sensors, metering, all the use cases under narrowband are typically small monitoring, remote monitoring, collecting little bits of data. And it talks about handy connections today. And again, we bring this up because that's really going to tell you what your battery life is. And then your projected message size, 50 times 100 or 150. And then, your data usage per day, roughly 100 megabytes per day, and there's a max. So it'll vary depending on your use case. And then the latency, for some of these use cases, 20 to 60, 10 to 20 for city lighting, parking, and every time you get under a millisecond, you're really not going to notice, unless you're on your computer or you're doing some type of video, which is a completely different application. But for narrowband, again, it's really designed for fixed type of sensors. And then, mobility, again, narrowband's not really designed to be mobile, so keep that in the back of your mind. It can be. I've had a tracking device we were testing, and I was in California from the Bay Area all the way down to San Diego. We actually drove. When I go out to California, I have so many meetings, I just drive because they're all over California. And we were able to track it all the way down. Now, the battery life, that's a different story, but it will work. So I'm not going to say it's not an application. If you have a use case where you have supplemental power, it's not just on battery, then you're probably fine with narrowband. So keep that in mind. There's a lot of cold chain management applications where you want to monitor the refrigeration inside of a truck, but you have power to it from the truck, and that's acceptable. That'll work just fine. So here's a comparison to a lot of the other technologies, starting with your 2.3G LTE, narrowband. It's not that it's T-Mobile's narrowband, it's just narrowband. So there's Sigfox and LoRa, which a lot of you guys are working on applications in Sigfox and LoRa. Nothing wrong with these technologies. You got to look at what your solution is and what your requirements are, and then pick what you think is best. You know, a lot of companies are price sensitive, so you know, if you look at obviously 2G, 3G module to build a device, the module itself is probably going to be $20, $25 for the module. If you look at narrowband, it's probably $5, so the price comes down dramatically. And then you look at Sigfox and LoRa, and I'm not that familiar with the pricing, but it's probably, what, under $1, guys, for the device sensor? Roughly a couple dollars. So, but then you look at, okay, what do I need for my transport as far as bandwidth? So you look at, you know, obviously 2G, 3G, LTE is going to be more. It says 300 megabits, but you go far beyond that. Narrowband, today with narrowband 1, your maximum is 230 down or 250 down and 230 up. So you're limited, but again, you're not really wanting to push a lot of data across narrowband. Same thing with Sigfox. So you go from, you got 600 bits and 100 bits compared to narrowband, and you've got LoRa, you know, you're just significantly less, but you're cheaper because, you know, those tags are much cheaper. So if you're tracking, say, for example, I mean, there's a lot of applications for like tracking cattle, for example. If you're just tracking cattle, that's perfect because you're not going to get a farmer or a rancher to pay, you know, 20, 30 bucks for each you know, cow that he has on his property. And then you have to look at which network has the best coverage for your customer. And that's where you have to kind of be agnostic. Obviously, from T-Mobile, I'd like to say we will have coverage everywhere, you know, but the other carriers will say the same thing too. And we're all working on it. You know, so that's a positive thing for your customers and for your business is that between all the carriers, we will have coverage, and then you'll still have the Sigfox and the LoRa technology as options to deploy what's best for your customer in pricing. So, you know, not one is really better than the other, just what is your use case and what you have to look at. What do we got here, Dave? Kind of redundant in data profiles. So again, we're going over the different use cases. Yeah, there's a lot of, you notice there's a lot of bicycles in Dallas and everywhere in the cities. Now there's, I mean, scooters too, so that's where narrowband is a fairly perfect solution for that. Again, it goes back to price. You can do it on LoRa and you can do it on Sigfox, so you have to really look at your use case and what your, you know, whether your customer is price sensitive as far as deploying an application. Okay, let's go a little bit into 5G now. So 5G evolution, okay, all the carriers are heading towards 5G. There's, I think, to a certain degree with consumers primarily, that 5G is going to give you everything that everybody talks about, which is the two things, multiple gigs bidirectional and under 20 millisecond latency. That's not necessarily true because there's more to 5G. Are all the carriers, including T-Mobile, yes, we're rolling that out. We want to roll that out nationwide. As you get to the rural areas that you don't have the luxury of densification that you do in the metropolitan areas, like, for example, downtown Dallas or LA. So it requires all the carriers to add small cells for the mid-band spectrum. That gives you your speed, okay? And everybody says, oh, we're going to have 5G, we're going to have speeds nationwide. We're going to have 5G nationwide, but the speeds are going to vary, so the technology may vary as well. We may not, we're not going to deploy mid-band spectrum that only travels 600 feet in a rural area. It's just not cost effective to do that, and if there's no one's using it, you know, it's not worth the investment. Whereas in your metropolitan areas, when you're supporting stuff like autonomous vehicles, autonomous air taxis, for example, yeah, you want that deployed downtown areas, and that's what all the carriers are doing. So it's, you know, again, next level, high speed, low latency, massive connectivity, moving forward, billions of connections, primarily in the metropolitan areas, and critical communications. Obviously, when we're launching these autonomous vehicles, we got to make sure that, you know, it's, you know, the network's reliable and deliver the speeds and the latencies that 5G has to offer. I touched a little bit about what requires to deploy 5G and densifications based on the spectrum that you have available. Since all the carriers have licensed spectrum by the FCC, that's critical to know and critical to have for the carriers as far as deployment. And so we talk about dense urban areas or metropolitan areas, because that's where your millimeter wavelength comes into play. Okay, higher speeds, because the signal is much higher, and a shorter distance. The higher the signal, the shorter the distance, more bandwidth, lower latency. And so if your signal with your millimeter wavelength, as an example, only travels 600 feet, then you have to add more small cells within that area every 600 feet. So if you look at downtown Dallas, for example, you're probably looking at 1,500 just in the downtown area, small cells are deployed to get you your maximum speeds and throughput. So when I talk about that and people say we're going to have it right away, all the carriers, all the cell tower companies like U.S. Tower and Crown Castle are working on that, and all these other partners that we use, and like all other carriers, they use contractors to build out these cell sites or locations for cells, and we co-locate with the other carriers. So I mean, we're waiting just like everybody else for these to be built. That takes time. There's lots going on with the cities. They want to charge the cell providers at one point in time, like $1,000 per site. Well, that's not economically realistic, especially if you're deploying thousands in a city environment. So I guess the FCC, from what I read online, kind of put that to a halt. The maximum, I think, is only like $100 to have, and that's a month. Fees for all carriers to pay to have small cells deployed. When you look at mid-band, you're looking at a little further areas, which is typically, your spectrum that travels further, not much further, probably a mile or two, a couple miles. But the throughput's going to be less than your millimeter wavelength, and your latency is going to be real close. It's not going to be significantly different. And then your low band nationwide. That is your rural areas. Like, for example, I'm really into the oil and gas and what's going on in the Permian Basin, because there's a lot of money being spent by that industry. And we don't have 700 out there, because at the time our focus was consumers. There's not a lot of consumers in West Texas, just a bunch of coyotes and lizards and stuff like that. They're not using cell phones. But the last probably 10 years, the Permian's gotten to be pretty big. The good thing where I think T-Mobile has the advantage is about just 2 years ago now, the FCC reformed 600, which was the old TV white space they used to transmit broadcast on, 600. And we're fortunate to win a bunch of 600 megahertz spectrum, I think like 45% nationwide, including in the Gulf of Mexico. And so now we've been rolling that out the last year and a half. And I just had a discussion with one of my potential customers out there, and our coverage for the Permian has significantly changed from a year ago. Now people are going out there with our cell phones that support 600, they have 71, and they're getting communications, they're getting voice communications. We have devices coming out now. We have actually had a device, one of the first device certified, which is a modem/router that we were testing out in West Texas, to provide connectivity for the rigs, etc., or if the oil companies have remote type of communications for all their facilities, control and automation type. And I'm going to give a shout out to BC Technologies. They're the ones that were the first to come out with that. It's been certified on our network. We're kind of excited about it. The other chipset manufacturers are coming out with their chipsets. But BEC was the first one to work with another chipset manufacturer and go to market with that, so we're kind of excited about that. So we're testing it out there now. Now, again, we don't have complete coverage, but the coverage is much better out there. And the thing with the oil companies, first of all, is they have to have two-way voice communications for safety. That's really critical to them. And then the IoT applications come in afterwards. So that's kind of an explanation about timing and what are some of the struggles, not just with T-Mobile, but the other carriers as far as densifying the U.S. for full 5G coverage. So, here's again applications. You guys, you're looking at this. The solution providers, the OEMs. You guys are all building devices, solutions, whether it's a platform that you're building for IoT. These are the traditional ones that you're seeing. Everybody's doing this. So it's really important is to understand, first of all, the devices, the sensors that are available on the market. If you're not an OEM, if you're an OEM, you need to understand the supply chain for the chipsets, like from the Qualcomms, the Tellets, the Gemaltos, and all those guys, because they're still building their chipsets, and they have to meet certifications for 5G, and that's kind of a moving target. So you'll see chipsets come out on the market and go away, but it's because they're trying to meet all the requirements. So the chipset manufacturers, from a logistics point of view, supply chain point of view, need to come out first with the module. Then the OEMs take that module and integrate it to the PCBs and create, whether it's a modem, a router, or a sensor. So really understanding that's important. Okay, that's the first thing. Second thing is connectivity. Okay, for your customer, is who's got the connectivity, whether it's narrowband, M1, LoRa, Sigfox, is understanding that. Okay, and then last is a platform. I have a lot of platform customers come to me, and there was an article in Gartner report that the biggest failure for platform providers is they don't understand the ecosystem as far as the modules or the connectivity. So understanding that is very important, okay, where you're at, because at the end of the day, platform providers make money if they're collecting data and processing it. If you're not processing it, you don't have any customers, so really, and that's where a lot of you guys come in that build, like OEMs and even the solution providers, understanding the entire ecosystem as far as providing a solution, and us as a carriers, whether it's AT&T or our competitors, where we're at. And we're all striving to provide nationwide coverage, and that'll be there. It's just going to take time. Our strategy is really no different than any other carrier strategy. Is one network. We want to be first to go nationwide with 5G, and I think that's one of the reasons why we started looking at the acquisition of Sprint. Sprint has a lot of spectrum, as I mentioned. They have fiber. That's part of the 5G strategy or spec, is having fiber to your towers, because if you're providing multiple gigabits to each device on that tower, you need to have the bandwidth. Doing a microwave backhaul is not going to cut it. You're getting about anywhere from 100 megs to 600 megs, 800 megs on microwave. But if you've got devices that are in the gigs that are consuming that much data, that's your bottleneck. Is going to be your backhaul. So fiber is really the key for that when you're talking about low latency and very, very high bandwidth throughput. Our 600 megahertz, we feel is an advantage to us because we can still deploy connectivity without having to have that many towers. We don't have to wait to provide extended coverage. A good example of that is West Texas. There's a very minimal amount of towers out there compared to other areas, but because 600 propagates further than 700, which I think AT&T has as well, we've got a little bit better coverage, and that's important, for providing coverage nationwide. And then we're all of us are starting to deploy millimeter wavelength in the metropolitan areas. Again, we're waiting on locations we can install small cells. It's not us. We're ready to go. All the carriers are ready to go. We're waiting to have that infrastructure in place. And then obviously the best ubiquitous mobile experience for our customers. If we have the best, then chances are we're going to get more customers. And I think all the carriers strive to be the best. I mean, we're always battling it out, saying who's best. At the end of the day, that's great for the consumers, great for your customers that we're doing that. And then again, multiple use cases. Some of the things I want to mention, you guys know the traditional ones, most of you heard about edge computing. Edge computing down at the RAN level. with the carrier, with equipment manufacturers, radio manufacturers like Nokia and Ericsson. They've got technologies where they're actually virtualizing the radio. It's all software based versus hardware based, and that allows them to do a lot of things. It's pushing edge computing down to the RAN level and not having to take that data to the cloud. And that's important. And what that does as well is if you're able to do some edge processing, you're not transporting data on your backhaul all the way to the cloud, so you're minimizing the amount of traffic. For example, on our core network, that saves us a lot of time and optimizes our backhaul. Kind of redundant slide. LTE, 5G, millimeter wavelength, 600 for rural areas is our strategy. These are some of the, and most of you maybe already know, especially if you're an OEM, the chipset manufacturers. Qualcomm's a big one, and then Sierra Wireless, just about all these other module manufacturers use Qualcomm chipsets. So if Qualcomm is delayed in announcing or developing a chipset to support 5G, that's what's going to be the delay as far as the technology being rolled out, to the rest of the public. Because everybody here is waiting on Qualcomm chips for the most part. There's some other chip manufacturers that are on the market that they could use, but for the most part, everybody, the big ones like Sierra Wireless, Intel, these guys, they rely on the chipset from Qualcomm. So it's not really the carriers, we're working on it, but it's supply chain, coming chipsets. So the OEMs could build devices that we can deploy on our networks. With that said, that's the end of the presentation. You guys are pretty quiet. So any questions?
You had mentioned a whole bunch of applications, but what are you seeing as the emerging killer app for 5G based on your experience and talking with customers? What is the one app
I can't tell you what the killer app is because I heard new tech. In my job, I deal with end users, I deal with solution integrators, I deal with OEMs that build out, and I deal with the module. Not necessarily, I hear what the module manufacturer is coming with, so I can position my OEMs to say, hey, look at this module or this chipset to build your device. I go back to saying, if you think it, you can do it, basically. And IoT is all about taking the real world and digitizing it, so we see it differently and we could analyze it. But the ones that were on the presentation, those are typical ones. There's other ones out there, and you just got to think about what's that new one. I will tell you that I have a lot of startups, smaller startups, and they have the highest rate of failure, and it's because they may have been in the industry. And I'll give you an example of one. He retired. He took, I don't know, $500,000 of his retirement and said, hey, I'm going to do a tracker. I'm thinking, okay, this is not good, because how many trackers are out there? There's a number of trackers. Pet trackers, tracking cows, tracking luggage, tracking parcels, tracking everything. Okay, they're just putting a different spin on it. And now you have to, then we have to deal with the module or the chipset manufacturers. You have to pick a technology and say, okay, for my use case, for what I'm developing, what module, which chipset's best? Is it narrowband, is it M1, etc.? You got to think about all those things. And then there's challenges when, let's talk about certification. That in itself could take you, a few months, 3 months to get through. And I tell everybody is if you can find something off the shelf to go to market with, the most important thing, and I think you guys will agree to this, is go to market. Speed to market. Because you could have a solution and you think that's the next best thing since sliced bread. 6 months later, you got competition. They've already deployed it into the market, and you're going to lose. And that's kind of the scenario that I have for this guy. Small, didn't really understand it. They all have aspirations of being the next billionaire, with their idea. But it always happens. I hear about this, I listen to them, And prior week and the following week, I hear the same story, same application. So my suggestion is, depending on where you're at, if you're a platform provider, look for the devices that are going to get the data to your platform, and then also with the carriers, you know, whether it's T-Mobile, hopefully it's T-Mobile. But, you know, the reality of it is, and it's like this with the other carriers, is that we may not have coverage everywhere you need coverage and vice versa. So got to look at that.
So if we have an LPWA platform and we're planning on integrating NB-IoT or something like that into our existing LoRaWAN activity. So if I'm reading through the tea leaves, Q420 will be, that's really when it'll be widely available for NB-IoT?
We want it to be, but again, I go back to towers being built, us deploying NB on a certain spectrum. Right now we have 2 and 4 as far as compared to band 12 or 700 and our band 71, that distance is a lot shorter, okay? So you may not have coverage. Now, in 2020, we're planning on, there's a firm commitment to deploying narrowband on band 12, which is 700. That's going to give you much more coverage with the existing towers that we currently are located on. You know, so that's going to give you probably, I don't know, 40 miles maybe from the tower. And then hopefully, I'm hopeful, because I'm excited about band 71, 600, is we'll have further coverage on that. So that'll probably be in the 50, 60 mile range with narrowband. Again, it's going to vary based on terrain and you know, signal propagation and all that.
And that same line, at my farmhouse, we have coverage from T-Mobile.
Yep.
It works if I'm 20 feet up a tower facing north.
Yep.
If I change, I don't have coverage. How is T-Mobile going to change their coverage maps to help people like that are trying to say, do I have coverage? Do I have sufficient coverage? Do I have reliable coverage? And then when it starts to fade out, how do I know it's a network issue versus a device issue? If you're running 10,000 units, it becomes a big cost.
Good question. So one important thing is, if your strategy is say, hey, I know T-Mobile's deploying narrowband on, say, for example, band 12 or 700, and I want to be part of it when T-Mobile deploys it on band 71 or 600, okay? You've got to make sure. One of the most important things, and I think all the carriers in the room will agree, is that with the challenge with bring your own device type of things, I'm talking about cell phones now, is that the customer doesn't understand which his module supports, his chipset, which band frequencies and all that. So number one, make sure you've got the right chipset to support our bands for whatever technology that you're looking at. If it's narrowband, there's a lot of chipsets that don't support bands 12 or band 71 today. So that's
if you're
really
comparing
important.
600 and 700, that makes sense. But in a lot of cases, you're dealing with a topography that means, can I use a carrier at all? Or do I have to bring my own base station to do that last RF leg in a private network like LTE, like LoRaWAN? That's really where it comes down to.
Yeah, absolutely.
Things have problems. We've all called cell phone companies trying to figure out why our calls are dropping. They say switch to Wi-Fi.
Yeah.
You know.
Our coverage maps, and I think that's the same with the other carriers, that's just basically predictive analytics. We're not looking at the contour of the earth at that location, because we really, unless we bring that into like an Esri file and use some more complex or GIS, we can't really do that. And even then, it's only predictive analysis. Okay. When I worked for the oil company in California, I spent probably about 6 months doing coverage mapping in all their leases throughout Central California. And other carriers had coverage, you know. So I have two recommendations, because I've been on that side of the house, is if you're considering a carrier, T-Mobile as well, is get a device. For example, what I'm doing in West Texas, now that I know that 600 is launched there, I'm not going to tell my customers, hey, look at our coverage map, we have coverage, because inevitably, this happened to me 9.5 to 10 at a time, 10 times in California, this is 5 years ago, that they didn't have coverage. Well, our map shows we have coverage. That's not the point. The point is, do you have coverage? So there's a saying, you got to put boots on the ground. And that's what I'm doing with the BDC device, is that we're deploying that with partner solution providers, integrators, and they're doing ground testing. I don't ever tell well, I don't say I ever, but I don't, because I've been there before, is that look at our coverage map, we have coverage. No, I say, hey, you know what? I understand what technology you're going with. Here's one of our partners that has a device that is optimized for our bands. Take that device out there. Make sure yourself you've got the coverage. Because if you don't, you're going to think, hey, he lied to me. I don't want to lie to you. I want to be real about it.
Yeah,
So
and that's a good approach. I guess my concern is if I'm managing a fleet and the radio conditions change and I start to get partial and I start having dropouts, today when I call it the carrier, it's real mundane. I mean, if I'm running 10,000 units, I need to get to tier 3 pretty quickly.
Yep.
Is T-Mobile setting it up so that some of these device guys have access to better troubleshooting or higher level technical expertise? Or is it, there's just another subscriber?
yeah, the customer that has well, it depends. I mean, if you're a direct customer of T-Mobile, you have access to that. And when I work with my customers, I mean, I'll go out and I'll talk to RF engineering. I was pushing RF engineering to start working with oil companies and seeing how we could deploy 600 megahertz faster. I'm not the only one in T-Mobile, but I was a big voice on that, whether they listen to me or not, because I'm a BDM out in the field, right? But my background, for 28 years was oil and gas. And you know what? Oil and gas has a lot of sensors. They're monitoring everything. And to me, the way I looked at it is because I didn't come from a retail type environment, and I'm in IoT, that's more commercial and industrial type of application. So you got to really understand that. So I pushed that. I mean, I stared at coverage maps. I talked to RF engineering. Okay, where's the cell sites? Where's our radios? Does it have 700 or 600? Because that was critical to T-Mobile. We didn't have 700. AT&T had 700. I think we didn't. And then, like I said, it depends on, to really do it right, if you find a person that gets it, he'll work with RF engineering, get tower maps. They'll tell you what spectrum we have, or that carrier has deployed, in our case 600, and I could map it out. And I could say, hey, we got 600 here, here, and here. Where are you deploying your devices? And then we can try to articulate whether we'll have coverage. But ultimately, I'm going to say, get a device, make sure it supports 600 or band 71, and take it out there. It's the best way to do it. Are all the carriers working on nationwide coverage? Absolutely, but that just takes time. So it's kind of a tough answer to the question.
With 5G, how's roaming going to work if all the carriers are using different frequencies?
Works fine. Basically, if we have a roaming agreement with another carrier, this is really more internationally now. And we do have roaming agreements with, I'm sure we do with AT&T, Verizon, Sprint today. In some areas we don't have coverage, we just partner together. It doesn't really matter on your spectrum. As long as you have that agreement, then you'll be able to roam and your device is compatible on that other network. I'm thinking more international, like if you're going to Australia or Mexico, which is Telefonica, or Rogers, they have similar spectrum. It's all about whether your device supports their spectrum. But roaming's not an issue.
Security. So 5G is going to allow for capacity, but as far as security goes, I mean, I would hate to be driving sitting in an autonomous car and somebody hacks the sensor on the road, which is right now they're all open-ended. So
Yeah.
what is T-Mobile's?
Did you mention blockchain?
I'm also dating a blockchain founder, so this is like constantly in my ear, and he did a lot of logistics in Hong Kong for a long time,
Yeah.
so he's very much involved in the cybersecurity world. So
Yeah, and from a T-Mobile perspective, we secure our network the best we can with the current technology, but there's going to be other companies and vendors that have more enhanced, like blockchain is probably a good one. There's lots of technologies today. It's as far as the carrier's point of view, is that we're relying on them to securing that, because we only have the data from when we collect it from the device through our core. Once we hand that off, we have no control of it. Okay, so if you're looking at a device that has an Ethernet interface and that's how you're connecting to the network for whatever reason, yeah, you can intercept that traffic, it's IP, etc. But we basically secure it, encapsulate that data through our network, and then hand it off. Now, at the very edge, if you're talking about a sensor, then, and again, I just hear this, I'm no expert, but there's certificates and all that you put at the module level. Some of these sensors and modems now use like ARM processing, and so you can put whatever it is for security on that device itself and secure it at that end. And part of, I know a little bit about blockchain with distributed ledgers, so that could be important too. So I think that's going to evolve as, the technologies, that is probably the number one issue to solve is security.
I would just add in that 5G does have advanced cybersecurity standards that were released last year. It is what makes 5G, it's going to drive us to 5G more so than 4G, which you had anything there.
So, on your original slides, you showed 2020 as the date that you're supporting 2G, right?
Sunsetting 2G?
Sunsetting, yeah.
Yeah.
And support, well, you didn't say you're sunsetting it then, you said support through. That's different than sunsetting.
Yeah.
You could leave the network on and still not support it.
And I will
right?
tell you right now.
So my question, this is
Go ahead.
what's the narrative in the field when you don't have narrowband IoT up through 2020 in most places? In your discussion, you talked about tracking cattle. You also made the statement you have coverage everywhere, and then you said you don't have good coverage in rural areas because you don't have the luxury of densification. Well, to the best of my knowledge, cattle are not roaming the streets in downtown Dallas. They're in rural areas, and you're not going to have the narrowband coverage out there. So what's the narrative with the client, with your client as a BDM out there, in transitioning them from 2G and 3G to these other technologies? Because right now, at the end of Q2, 113 million cellular IoT connections in the U.S., 71% of them are 2G and 3G. So what's the narrative with the client?
So narrative is that, we still have 2G or 3G and 2G. 3G, it's pretty much confirmed we're going to sunset that in 2020. 2G is still kind of open. And the reason why is because we got third world countries that have roaming devices. And if their default is 2G, then we still got to support them. Now, I can't answer the question as far as sunsetting from the other carriers. That's a separate discussion we'll have with them. But as far as coverage, we're all working on it, period. I mean, at the end of the day, can I tell you, we're going to have narrowband coverage nationwide? We're working on it. Someday we will, maybe. I don't know. It depends what the strategy is. And, and again, one of the factors for us, not necessarily a factor, but, 600 is propagation signals much further. That helps.
What's your former employer, the oil companies say about this stuff?
They're building out their own networks, period, right now, okay? But I will tell you that, there are discussions with companies in Houston, all the majors that are operating in the Permian. They don't want to maintain their own infrastructure. It's too costly. So, the strategy is, as a carrier, T-Mobile, working with them, they've already built, I mentioned earlier that it hinges on, our coverage for all the carriers hinges on how many towers are built and where they're built at. Permian Basin is a good example. Most of the oil companies they have significant investments, they have fiber to their own towers. They don't have licensed spectrum. So the strategy for us, T-Mobile, is to partner with them, utilize their infrastructure, put our radios on there, provide that coverage. Not that we don't want to, I go back to supply chain. Towers are a supply chain. If those towers can't get built, we can't provide coverage in that area. So we got to look at more ways to provide coverage. But ultimately, all the carriers, we want to provide coverage nationwide. So, hope that answered the question. Anything else?
One more. Biologically speaking, we have an electromagnetic force that's in our body. It's 60 times that in our heart, then our brain, and all these other things that I feel like aren't being addressed as far as impact of 5G on our actual bodies? Do you guys do any testing, or is that a dialogue that you're pursuing?
I can't answer that question because I'm not
I
that
can
part
answer
of the
that one for
company.
you. So FCC has a set of compliance regulations called SAR, specific absorption rate testing,
Okay.
which relates to RF frequency going into the body. And so whenever you get a product tested, you do like EMI or FCC certification. There's also the SAR certification. Same thing with laptop computers. Anything within 12 centimeters of the human body is required to have an SAR test done to it to make sure it doesn't go beyond the specific absorption rate frequencies. We found in research that within 12 centimeters of the human body, you can start having cellular degradation. So when the FCC sets that limit, and now with 5G, they're going to be modifying the SAR regulations for that. The problem with RF frequencies, it's magical. We still don't really know what's going on. We forget that asbestos, years ago, everyone thought it was so safe. There were even scientists who were eating it on black and white TV because it was totally safe, and then later we found out it's really bad for you, right? So RF, we really don't know, but as we progress with technology, the FCC is moving to increase those regulation compliance issues. So if you need help with that, Avnet's here to help.
I've also seen some of the testing results on 2G and 3G. And when you have your cell phone up to your ear, the RF energy penetrates halfway through your head. Which is why they recommend using that cord.
Of course, the 60 hertz that you're standing next to over there also penetrates through all of our heads right now.
I'm sure, I can't wait.
That may explain a lot. You know. One last question.
I got one.
Okay.
Do you guys have any plans with CBRS or private LTE?
Not that I'm aware of, well, today.
That was actually my question also. I had a very interesting conversation with a representative from Qualcomm, from the IoT group, and they actually had, there's one of the large shippers, I should say, and he wouldn't tell me which one, actually took out over 100 Wi-Fi nodes and replaced it with 4 private LTE nodes, had better coverage and better speed, and all the issues that you typically have with contingency with products that are mobile devices moving around, completely eliminated the problem in one of their facilities at the ramp. So, encourage you to look into that because eliminating Wi-Fi.
Yeah. Yeah, there's use cases, there's certain conditions. Anytime you go in an area that's really dense, no coverage. For example, airports are a good thing. We don't have a lot of, we got towers on the outside of the airport, and it's trying to get into the baggage area, where you got brick walls, you got steel, you got everything, and that affects your signal. So you got to look for the signal that's going to propagate. That, you mentioned, it sounded like it was an airport situation. So they have luxury. You can go in with like a LoRa solution you can place, or RFID tags. Those are cheap. That's where your use case comes in, and looking what the customer's pain points are. T-Mobile's not going to go in and put, we can probably put small cells in. That's a whole different story in itself as far as dealing with politics at these type of facilities. But going in and putting like a Bluetooth tag or a beacon or whatever the case is for short distances, and putting multiple in that type of environment works perfect. So, I'd say, look at your use case, look at your conditions.
Next question.
Just quickly, to follow up on that, I worked in an overseas market, and one major difference is the in-building and the campuses. What's your take, my observation, and it's only an observational take, that
DAS and IBS is not as big at least in the markets I've been here with Atlanta or here, as opposed to other markets in the world. There's not much emphasis on coverage inside campuses and buildings as opposed to outside. Is that a regulatory thing? Is that a business decision?
No, it's quite the opposite. Is we have customers, large customers that need in-building access because now they're deploying instead of connecting to the Wi-Fi. These companies that are deploying solutions with these companies want a direct connection because if you connect to the Wi-Fi, and something changes internally and dealing with all the politics with IT groups, throughout the organization, it's very difficult. With LTE backhaul to like a router or whatever, they can manage their internet, they control their connectivity. But no, we do a lot of in-building upon, with requests to the customer, so it's really understandable.
I think that's the key difference. It's probably more reactive and a request as opposed to a carrier's set of procedures.
Yeah. I don't think any carrier is going to automatically provide in-building. They got to get a request from the customer.
Great. Let's give him a hand, guys.